Now I'd like to introduce myself to begin our presentation. So my name is Kaur. I'm digital manufacturing engineer implementing digital factory projects, mainly focused on robotic simulation, ergonomic simulation, and discrete event simulation through PLM platforms, especially with Siemens Technomatics platform. I have 9 years experience in this digital world, and the vast majority of my projects were aimed at the automotive industry. So today we will start with an overview about robotic simulation. We will focus on simulation softwares, benefits, features, types of operations, and other simulation capabilities before taking questions. And the message I want to bring in this webinar is how can we increase our efficiency and productivity through the application of robotic simulation? What does this bring us benefit and advantages? How it works and what can we simulate? And after all, what is robotic simulation? So robotic simulation is a digital manufacturing solution that allows us to build, to test, and to validate a 3D manufacturing environment and to perform simulation of industrial robots. So we are able to simulate complex robot work scenarios, check for interlock conditions, check for possible mechanical interferences, and cycle time optimization. It is mainly used in the pre-planning phases of a project where everything can be tested and validated even within a controlled environment. In this way, the problems can be detected in advance without impacting the real environment, and the problems with new installations are avoided. In addition, it can also be used for existing installation, so we can create and we can test scenarios in order to identify possible improvement proposals. Here I have some robotic simulation software options. These are provided by the robot manufacturers themselves. So we have software KUKA Sim from KUKA. We have RoboGuide from Fanuc. We have Robot Studio from ABB and URSim from Universal Robots. And each of these programs allows programming only one type of robot, only the model of its manufacturer. On the other hand, we have also some universal solutions for robotic simulation. I mean, they are applications that have the ability to simulate different robots from different manufacturers at the same time within the application. So we have, for example, Process Simulate software from Siemens. We have the OEM V6 from Dassault Systems. We also have the Robot Expert from Siemens and Robotic from Robotic company. Here we have listed two Siemens robotic simulation software. Both have the same graphical interface, but there are differences in the ease of installation of Robot Expert, as it doesn't have a link to some database like in Process Simulate, but we have some limitation as the possibilities of simulation. In Robot Expert, for example, it's possible to simulate only material handling, only manipulation process, and continuous operation like gluing and arc welding. It's not possible to simulate, for example, welding operations. So in this case, Robot Expert is best suited for small and medium-sized business, and the Process Simulator ends up becoming the most complete of Siemens platform, facing the direct competitor OEM, which are the biggest players in the market in terms of digital manufacturing platforms. We have listed here some more recent applications. They are also universal. We can simulate robots from different manufacturers at the same time within the application, and that also gives us the possibility to generate a robot offline program. So we have Visual Components from Visual Components company. We have Octopus software from Octopus company and Robot Master from Robot Master company. And what basically differentiates them are the menus, are the graphic interface, are the extensions of the mathematical models, the 3D that can be included, and some other specific features, specific particularities of each software. Well, and what benefits does this bring us? So here we have listed some of the benefits of robotic simulation. So for example, we can reduce modification costs and production risks through prior analysis and immediate detection of possible problems. We can reduce the number of building physical prototypes since we can validate them through the virtual environment. We can optimize robot trajectory cycle time. And here we have two situations. We can, for example, create a new trajectory already inside the simulation environment, or in some cases, we can download the real robot program. We can upload it to the robot from the virtual environment and rework its trajectory within the virtual environment. And this brings us more flexibility, more speed in the changes, and avoid possible problems in the real environment. In addition, focusing a little bit on the virtual commissioning part, we are able to validate the functioning of mechanical devices through the creation of kinematics, and also validate the PLC logic and robot logic within the virtual environment. And with all this, we obtain improvements in the production process and increase the quality of the process through the entire life cycle of the product. Here I'm giving an example of the main features of robotic simulation. So the applications allow us to analyze process within a 3D environment, allow us to create 3D simulations. We have the ability to create kinematics for mechanical devices, machines, grippers, opening and closing clamps, for example, welding guns, cylinders. We're able to create all the robots offline programming. That is, we can connect the virtual robot with a real robot controller. We can parameterize its trajectory with correct speeds, with real types of movements, robot signals, release signals, and other parameters like gluing parameters, for example, or welding parameter. So it's the step of detailing the program before downloading and load it into the real robot. And we can also work with virtual commissioning. It means that we can validate the robot logic and PLC logic within a controlled environment still in the planning phase. In this way, we don't affect and we don't stop the real production environment. Well, in this slide, I will show some examples of robotic operations. There are some possibilities such as pick and place operation, material handling, spot welding operation, continuous operation such as gluing, deburring, and arc welding, and also paint simulation. So in the first case, the first scenario, we have an example of a material handling operation. This is for palletization process. So here the robot pick and place the pallets, pick and place the plate, and pick and place products under the pallet. In this case, we are considering an ABB robot specific for palletization process in an universal application. This is Process Simulate from Siemens. So here we have a robotic cell with some robots working on welding a set. Then we can create our weld points on the product and simulate all the robots' internal conditions. We can find the best positioning for them so that they don't have interferences, and we can find the best access sequence for them. We can see in detail in this video some welding points and the opening and closing movements of the welding gun, as we have all the kinematics created for the welding guns and for the clamps, for example. On this slide, we have three examples. These are for continuous operations. So we have arc welding operation, we have deburring operation, and stationary glue application. Basically, here we created some continuous paths. As the name implies, we define a start point, we define an end point, and then we create all the other locations manually or through some offsets based on the start and the end point. In the first example for the arc welding, we are using a universal application. In this case is the OMIA V6. And for the other two examples, for the burring and gluing operation, we are using Process Simulate from Siemens, also a universal solution. Here in this last example, we have a simulation of a painting process on the roof of a car. And in this case, we have a robot under a 7th axis with a painting gun. And here we can create, we can analyze, and we can validate the paint layers. We can adjust the thickness, we can adjust the distance from the tool to the point of application, we can adjust the angle, we can see if there are sections with paint accumulation, for example, and we can also generate the robot offline program. And now I'd like to show you some other example videos for robot offline programming, some other possibilities, such as the inclusion of a point cloud into the simulation study. I'd like to show what's new within the simulation environment as a direct connection with the real robot. This is a specific case with universal robots and Process Simulate, and even virtual reality. Okay, so we enter here in the robot offline programming stage. This is a very important phase where we connect our robot with the real robot controller and where we parameterize its trajectory with real speeds, with real types of movements, linear movement, circular movement, joint movements, for example, where we include the release signals, the robot logic, and all the axis configuration in order to export the program and load it into the real robot. We can also work with the insertion of a 3D point cloud, and this helps to save effort modeling devices or modeling static parts and other areas of the scene. So we can turn things on and off for a better visualization. For example, we can check for collision detection or take measurements. And it allows to adjust the simulation layout according to an as-built plant and to visualize the assembly process in the real plant context. Here we have another resource that allows an interactive online programming of the robot with a direct connection to the robot in the simulation environment. And basically here we select the robot we want to work with in the simulation. We connect it directly to the IP address of the real robot. We activate the live mode and the robots are connected. So in this way, the simulation robots follows all the movements given to the real robot, and this allows us to detect possible collisions. Since we have already modeled the entire virtual environment, we already have the entire structure and the entire work area around the robot in 3D. So this is another way of optimizing the programming process, just for the creation of a material handling, like what we have in the video, for example, exclusively for universal robots and process simulate from Siemens. This is a unique capability. And finally, we also have the possibility to load a simulation study within a virtual reality environment. And with that, we can see the study in detail is still in the planning phase. We can, for example, teleport to any region of the layout. We can take some measurements. We can make some markings and send them to the maintenance team or to analysts or to other engineers who are working on the same project, for example. So this turns out to be an easier and a more intuitive way to analyze the process. This was our webinar today. We covered a little bit what is robotic simulation, what types of current softwares are on the market today, what are the benefits, features, possible types of operations, and some other examples of possibilities, unique capabilities within these applications.